So I just wanted to talk a little bit about what you're doing today in class. Please don't overthink, especially this worksheet. A lot of it is just your ideas about how you're understanding things so far. Um, so you're asked to fill in some things up here. It's just a multiple choice question and then labeling some stuff on here. And then what you think is the actual centripetal force causing these objects to stay in a circular motion. What do you think about that? And then you're going to be doing some labels on here. You're showing me the normal force. Normal force is that force caused by the surface, and then also the force of gravity. Where do you think gravity is going to be the bigger force, and where do you think normal force is going to be the bigger force? Think about what we did with the elevator on Monday, okay? And then there's a few more questions. So this page is really more conceptual based, okay? The second page that you're going to be doing is more math based. And so we're going to be dealing with some free body diagrams and doing some different calculations and really bridging things together. So I wanted to go over an example calculation with you guys so that you understand the procedure. So we're going to do these first two together, and then I have a little procedure written on the key that this is how I want you to work through solving these problems, okay? All right, so we have a bucket of water, which has a mass of 2 kilograms, is attached to a 0.8 meter or 80 centimeter long string and spun in a vertical circle, okay? The speed of the water at the top of the path is 3 meters per second. Okay, so what we're looking at here is filling in all of this information. The first thing that you're going to want to fill in here is the force due to gravity. That's actually the easiest thing to do because they're giving you the mass in these different problems. You know you are given how many kilograms in every problem. And we know that gravity, force due to gravity, is weight, how heavy something is. And that's literally just mass times acceleration due to gravity. In this case, 2 kilograms times 9.8 meters per second squared. So that is going to be 19.6 newtons. The next thing that you are going to do, you're going to skip calculating tension. You're going to come down and calculate your acceleration. Okay, so we know that we can calculate acceleration by using the formula acceleration, centripetal acceleration, is velocity squared over r, which is the radius. So that's going to be the length of our string. So then all I did was 3 squared, which is 9, divided by 0.8, and I got 11.25 meters per second squared. And the direction that is pulling, oh, I'm realizing this is at the top of the circular path, and I'm dumb, that should have said down. Oops. I mean, the arrows are literally pushing down, like, duh. It is 6:45 and I'm still here. But I love you guys, and I'm sorry that this isn't more exciting. Okay. Then the next thing that we can do is figure out our net force, because this is Newton's second law. F net, or the sum of the forces, is equal to mass times acceleration. Okay, so that's what we're doing here. Our mass is 2, and the acceleration is 11.25, so that means our force is 22.5, also down. So that's my third step. My fourth and final step is going back up, and we're going to find the difference. If my total force has to be 22.5 newtons, and I know that gravity is applying 19.6 newtons to the bucket, then tension has the leftover bit. So I'm going to do net force, which is 22.5, minus gravity, which is 19.6, and I get 2.9 newtons as my tension. So let's go ahead and do the same thing on this example, just so you guys get the idea. Okay, here the bucket is still 2 kilograms. String is the same length, but now we're at the bottom of the circular path because the string is pulling upward here. And so gravity and tension are fighting against each other. See how tension is bigger in this one. Okay, so first, gravity is going to be the same amount. It is going to be still 19.6 newtons, okay, but it's pointing down. Our acceleration is going to be going upward, okay, because it has to be pulling in this direction. So to figure out my acceleration, we are still going to do velocity squared over r, so 36 divided by 0.8. That gives me 45. It's a biggin, okay? That means my net force, excuse me, my net force is going to be this number times 2, so that's going to be 90, and that's also up. Notice that gravity is acting down though, which makes it a negative number. Okay? So now when I figure out my tension not only has to apply a net force of 90, but it also has to counter this 19.6. So my net force is actually going to be 109.6 newtons, because it's here not only having to supply that net force of 90, it's also having to counterbalance that 19.6 newtons. Okay, so that is the procedure that you're going to be applying to this worksheet. So again, the first thing that you can do is calculate Fg. That is your weight. So Fg is equal to mass times gravity, 9.8. Then you're going to calculate your centripetal acceleration using the formula v squared over r. That's your speed divided by the radius. And then we have calculate your F net, and that's going to be just mass times acceleration. So whatever the m is times whatever you calculate here. Calculate your tension or your normal force is the last step. So you take the answer that you got here, your mass times acceleration, and then we're technically subtracting Fg, and if they're going in the same direction, we're going to wind up, our F net would technically have been negative here, and this would have been a negative 19, and so then we would have been technically adding, and so you can see why we have a smaller number right here, whereas with this example, this is 90 newtons up, so that'd be 90 minus a negative 19, so it's more like 90 minus negative 19.6, so that's where we get 109.6, whereas on this side we have negative 22.5 minus a negative 19.6, and so when we do that, it's like adding instead. So it ends up like adding, but this was started out as negative, so that's why we get the negative 2.9 here. Okay, so keep that in mind in these places where they're acting in the same direction. You're going to be basically subtracting because this is helping to create the total, and then when they're going opposite directions, you're basically going to end up adding because your normal force in this case is having to support the weight and also cause it to accelerate. So it's kind of counterintuitive, but with some practice going through that procedure, I think you guys will be okay. And I hope you have a really nice day today, and I will see you guys on Friday.